Why does this get too big? Oh. All right, so I'm going to do something a little different this time. We're talking about loops, and we talked about three kinds of loops. We talked about, what were the three kinds of loops? Question type loop, special value type loop, counter control loop. And I told you that you'll need to know those terms for assignment 4, and then you can completely forget about them if you want to. But everything we've talked about so far is while loops. Okay. What we're going to do today is move on and talk about a couple other C++ loop constructs besides while. I'm going to do this a little differently because instead of, I don't want to spend a lot of time on it. I'm not going to tell you the construct and then do an example and run it and all that stuff. I'm going to try to move a little more quickly on this. So I've got actually the lecture notes up here, and I just want to kind of go through them a little bit. By the way, the lecture notes, oh, all right, never mind. I've changed them since okay, never mind. All right, so the first other type of loop besides a while loop is a do-while loop. And you can see the syntax for it right down here. Okay. Basically, that's exactly the same thing as a while loop, except what's different? The while is at the bottom. Now, in a while loop, does the condition get checked at the start of each iteration or at the end of each iteration? Okay, so at the start of each iteration, that's true. Okay, that's not a wrong answer. But I was kind of asking a trick question a little bit, because what's the difference? If you've got iterations one after the other, whether you say, really what you're saying is you check the condition between iterations, right? Whether you say at the end or at the beginning, doesn't matter. Does that make sense what I'm saying? Go ahead. Okay, so the only difference is that with a do-while loop, it runs that first time once before it checks the condition. Okay, that's the only difference. So, in a situation where the condition is true, so I'm gonna like make an assertion here, and if you understand that this assertion is true, that kind of tells me that you understand the difference. Okay, if the condition on a while loop is true when you get to the while loop, it's not going to matter whether you use a while loop or a do while loop. You're going to get exactly the same thing. The only time it would be different is if the condition was false when you hit the loop. Right? Let me say it one more way. Once you get going in the loop, there's no difference. Right? The only difference is whether you executed that first time or not. Okay? So I have a little example here. Well, here's how I say how to decide between a while loop and a do-while loop. Use a do-while loop if you know that the user will want to execute the loop at least once. Although that's kind of a weird way to say it, because what if we're not? So a lot of times we're using loops and it's not related to the user at all. It might be related to something else, like an input file or something like that. Anyway, so I guess I should say if you know that the loop is going to get executed at least once, and use a while loop if you aren't sure. Okay. I actually, since I wrote this, I actually have kind of a different suggestion, and you can take whichever one you like. But my suggestion now is more, just use a while loop, and then if you think that maybe a do while loop might be better, then you write it as a do while loop and compare the two and see if it really is. Okay. The only reason to use a do while loop instead of a while loop would be if for some reason it made your code cleaner. Does that make sense? It's not like you can do something with a do while loop that you can't do with a while loop. The only reason for having a do while loop is in case it makes your code cleaner. And frankly, I rarely see that situation. So my suggestion is just to use a while loop. Because what happens for a lot of students will write something using a do while loop, and it turns out that you really didn't want it to execute at least once, and so you get in trouble. Okay? So that's my suggestion. So I have, oh, here I say it right here. My recommendation is you always start off using a while loop. You could switch to a do while loop if you finish a program and decide that you could clean up your code a little bit. See, I actually wrote what I think there. Okay, here's just an example of the same paycheck problem that you've seen over and over again. We did it using while loops at first. Here it is using a do while loop. I don't have much to say about it. Take a look at it for a second. Tell me if you have any questions. It's just exactly the same thing, except I've got the while moved down to the bottom. Yes? Yes. Although that's the same thing that happened with the while loop, right? I mean, so either way, that's the first thing that's going to happen. With the, oh, I see what you're saying. No. Okay, you're right. With the while loop, it first asked, is there an employee to process? Right, and it doesn't this time. It just dives right in, assuming that there is at least one employee to process. Right. Could we use it to eliminate priming the loop? Well, yes. In a case where you know that you're going to execute the loop at least once, you could use it to avoid priming the loop. Is that a huge win? You know, I mean, it might be a little. There might be some advantage to it in some cases, but really, no. Yeah, if we know the user's going to if we know that the loop is going to execute at least once, yeah. Yeah. All right. Actually, it's my phone. Sorry, turn it off. But it sounds almost exactly the same as when someone raises their hand on the thing, yeah. Okay, so any questions about this? Anybody want me to leave this code up here longer? Okay. Could one of you guys turn the light switch off for me? Because I can't walk over there with my headset on. I'm attached to the computer over here. Wrong one. There you go. Okay. Here's an example of using a do while loop for a special value type loop. Okay. In this case, it makes really no sense at all because it's exactly the same thing, right? In the previous case, it was a little bit simpler because we got to avoid the priming the loop. In this case, we always have to start with enter hours worked and then read in the hours before the loop anyway. So it really doesn't help at all, right? Even if we do know that the loop is going to get executed at least once, we still have to start by asking the hours worked outside the loop. I'm just not, so the reason that there's silence is I'm just thinking about that last statement to think about whether that's really true or not. Okay, so I could move it inside the loop, but if I move it inside the loop, then I would still have to, then I'd have to put all this in an if statement, right? Because on the second time through the loop, they might enter -1. Right. So I don't think there's any way to win. I don't think there's any way to make a do while loop simplify the code. Question? Okay. Okay. All right. Any questions about this one? Okay. So I'm expecting that you'll probably never use a do-while loop in this class, unless you want to for some reason. You know, you may choose to. Just make sure you don't use it and end up making your code worse. Okay. You do need to understand do-while loops for the exams. Okay. So what you really need to have a good understanding of the fact that it's the same as a while loop, except that it gets executed at least once. Right. As long as you understand that, I think that you'll be okay. On the exam, there might be something like, are these two loops exactly the same? And there'll be a do loop and a while loop. Or under what conditions will these two loops behave differently? Something like that. All right. I think I'm done with do while loops. All right. So here's a quick review of what we've done so far. Okay. Loop patterns are those just the things I kind of made up. And the question type, specified type, counter-controlled. And then C++ loop constructs are actually different ways of writing your code in C++. Different words that you use or different syntax that you use. A while loop and a do while loop. That's what we've done so far. We've got one more thing to talk about, and that is we're going to add one more loop construct, and that's the for loop. Okay? For loops are useful when you are writing a counter-controlled loop. Okay? Some programmers will use a for loop even when it's not a counter-controlled loop sometimes. But what I am going to have you do in this class is every time there's a counter-controlled loop that you have to write, always use a for loop. Every time, and if and only if, right? So, and don't use a for loop if it's not a counter-controlled loop. That make sense? I could have said that better. If it's a counter-controlled loop, use a for loop. If it's not a counter-controlled loop, don't use a for loop. There we go. How's that? Okay. All right. So let's take a look at a counter-controlled loop. Right. There was our basic pattern for a counter-controlled while loop. Now, here's how we would use a for loop to implement the same thing. Okay? So, basically, what we've done here, this is a matter of convenience. Convenience and making something easier to read and understand, okay? I said that in counter-control loops we had three things, right? We had an initialization, a compare, and an increment, right? Those three things in a for loop are all combined and put right here in the loop header. That's all we're doing. We're taking the count gets 0 from here and putting it inside the loop header. We're taking the comparison from here and putting it inside the loop header, and we're taking the increment from here and putting it inside the loop header. Okay? So in one line, you can see everything you need to know about how many times the loop is going to go and what numbers it's going to equal, right? Okay. Now you know, so the way this works, to be more specific, we need to be careful here. This count gets 0. Gets executed only once before you dive into the loop, right? So when you're looking at a for loop, and if I ask you on an exam, what's the result of this for loop, and you're kind of tracing it through to see what's happening, you got to remember that that part only gets executed once before you dive into the loop. Okay. By the way, if you see any EPEs, no, never mind. I won't say that. Okay, this is the loop just like it is in the while loop. Okay, so this is going to get tested every time you are at the top of the loop. And if it's false, you're going to be done with the loop. Okay? And then this statement, interestingly, gets executed as the very last thing in the loop every time. Okay? So that explains why when I gave you this pattern, I wanted you to keep the count plus plus at the bottom of the loop, because that's in what if you use a for loop, you're forced to do it that way. It always occurs as the last thing that happens in the loop. Okay? Any questions? Okay. All right. So I guess you can probably figure this out just by looking, but just to be explicit here, what you have here is you have 3 parts, and they are separated by semicolons. Okay. So you've got the initialization, then a semicolon, then the comparison, and then a semicolon, and then the increment, and you're done. You can use a for loop, and you can leave out one of those items. Okay, so for example, if I wanted to leave out, let's see, if I wanted to leave out the increment, the initialization, I could do that just by having the semicolon be the first thing inside the parentheses. Okay. I would not recommend doing that. Okay, because the whole point of the for loop here is that you've got everything right there on that line. And you don't have to go hunting to find out what is count initialized to. It's right there. So my recommendation would be always follow this pattern. But you will see in code sometimes people will leave off this one or they'll leave off this one. Okay? Yes? Would there be a reason you wouldn't want to visualize it? Like if you got 2 for loops, one goes to the other, something like that? So the question is there a time when you would specifically not want to initialize count? And I suppose that that's possible. It would be interesting to sit down and try to actually come up with a situation like that. So I'm not going to promise that that's possible, but I will say, okay, if that turns out to be the case, then okay. Right. I've done quite a bit of this, and I don't think I've ever encountered that situation. So, all right. So, just like with a counter-controlled loop, my recommendation and the way that you should use a for loop in this class is you just think of it as a template, right? Here's the for loop. The only things that might change are the 0 might change. You might want to start at something different. The thing you're counting up to might change. And the increment might change. Okay, and so I've been using the word increment. Really, probably a more generally correct term would be the word update. Because, for example, you might want to print out all of the even numbers. And so the way you would put there would be count gets count plus 2. Instead of what we have now, which is count gets count plus 1, right? Question. Could you have 3 pluses? No. The question was, can you have 3 pluses, count plus plus plus? The answer was no. What would the syntax look like for instead of increment times 1 by 2? Then where I've got highlighted right there, you would just replace that with count gets count plus 2. Or you could say count plus equals 2. Right. I don't think I've talked about that syntax. I'm not. I did. Okay. But only with plus. It can be minus equals or times equals or divide equals. So yeah, you could, if you wanted to go by 2s, you could put count plus equals 2 right there. But really, what you need to know is that what goes right here is a statement, right? Really, you can put any statement you want there, and C++ will be okay with it. You can put a cout statement there if you wanted to. Okay. I wouldn't recommend doing that because that's not really what that position in a for loop is intended for. Okay, but you should understand that you can put any statement that you want there. Same here. That's just a statement. You can put any statement you want there. Okay. In fact, well, let me finish. And then this part, the part between the semicolons, is not a statement. That's a logical expression, right? That's getting tested. So the syntax, one way to say it would be statement, logical expression, statement. So let me just tell you about talk a little bit about if you really wanted to use a for loop in a way that I would say is kind of crazy and reckless. Okay, you could have a lot of fun with for loops if you wanted to play with people's minds, because like I said, you can put anything you want here, and you can put anything you want here. Okay, so really, if you wanted to, for some and the other thing I need to tell you is that in C++, in this position right here, you can have more than one statement if you separate them with commas. Okay, I'm not recommending that you do that, but you could do that. So really, if you wanted to, you could put right here, instead of having all the statements in your program that come before the for loop, the way you normally would have them, you could stick them all right here in that position, inside the parentheses. Does that make sense, what I'm saying? So you could have open paren, and then your entire program up to that point, and then a semicolon, okay, if you wanted to, right? And here, you could put the entire body of your for loop right there if you wanted to, right? With the statement separated by commas. Probably not a good idea. Now, you probably won't see that in real life, but if you go out there in the real world and look at some programs, you will probably see people doing a little bit more than just having one statement right there. For example, if there's two counters involved in the loop and they're doing different things, then you might see somebody initialize both of them here and update both of them over here, even though only one of them might be in the condition there. All right. One more thing you might see, I'm just going to show you one way that you might see a for loop used. Okay. I'm not expecting you to look at any of this text here. I'm just expecting you to look at the code, right? So here's a for loop that is not being used in the way that I have suggested, but it's a use that you might run into if you go out there. Okay, so what I'm trying to do here is I could just try to brainwash you and say that the only good way to use a for loop is like I tell you. But what I'm trying to do is say, well, here's what I think, but you go out there and you're going to see some other things too, and it's up to you what you think is the good way to do it. So here you've got the initialization, that looks normal, and you've got the increment, and that looks normal, but instead of the usual condition, you've got number not equal to -1, which looks sort of like a special value type loop, right? So really what this is you're using a for loop to implement a special value type loop. And this would work, okay? Because you're initializing count to 0, each time through the loop you increment count, and you can imagine this being replaced with just a while numbers not equal to -1, the way we did when we were just using while loops. Okay? So just throwing that out there. All right. So what I have now in this next section is, I could spend like 2 whole days giving you different, working through different examples of for loops starting from scratch. I decided we should probably try to move on. And so what I've done is I've taken all of those loop examples, the counter control loop examples that we did using while loops, and I've rewritten them using for loops, just so you can take a look at how it looks. That makes sense? So remember the first for loop example we did, the first counter controlled loop example we did was just print out the word Dave 10 times. Remember that? So there's that. So stare at that code for a second and tell me if you have any questions about it. Okay. Anybody want to look at that longer? Okay, so the next example was allowing the user to enter how many times they wanted the name to appear. So that's just that. That makes sense? Well, I guess I might as well show you the output too. Okay, not much different from the example we just did, except now instead of having it print out 10 times every time, I'm asking the user how many times they want the name to be printed. The next example we did when it was we had the user enter a number and then we printed out the numbers from 1 up to that number. Okay, so here's what I have for that. Any questions about that? Now here you could have said what? You could have said, so let me back up for a second. The weird part about this is that instead of printing out count, I'm printing out count plus 1. That's a little weird, right? So you could avoid that by starting count off at 1 instead of 0, and then using less than or equal here instead of less than. So it would be count gets 1, count less than or equal to the max number, see out count, and you'd get the same result, and it might make a little more sense. Yes. You mean in putting an expression in a cout statement? No, you can put more. You can put whatever kind of expressions you want in a cout statement. I don't have a problem with that. I think that last time or the time before we may have talked about how sometimes there may be some advantages to not doing it that way, but assigning it to a variable first. Okay, so that's just kind of a judgment call. Whether you want to just put the whole expression in the cout statement or whether you want to assign it to a variable first and then just put that variable in the cout statement. Okay. Okay. The next example we did when we were talking about for loops is, when we did the counter control loops, is we wrote a program that printed out the sum of the numbers from 1 up to whatever the user entered. And so here's that. Okay, and again, I could have, instead of going from 0 up to less than max number, I could have, this might be a little bit simpler if I said count gets 1, count less than or equal to max number. And again, the reason that, I'm thinking back why I picked these particular examples. The reason that starting at 0 and using less than isn't working very well with these examples is because I specifically set up the example to start at 1. Right? I said count from 1 up to 9. Or add up the numbers from 1 up to whatever. That's rarely going to actually be the case. And so most of the time, starting your loop off at 0 is going to be fine. Any questions about that code? Yes? Yeah. That, right. So this statement right here, I'm repeating the question and answering it at the same time, could be replaced with sum so far plus equals count plus 1. Okay? The count plus 1 would sum so far plus equals count plus 1. Wouldn't have to be in parentheses, but it probably might be better to put it that way for readability purposes, because the plus has a higher precedence than the plus equals. So, yeah. Oh, that's a great question. Could I replace count plus 1 with count plus plus? Does count plus 1 do the same thing as count plus plus? Count plus plus does the same thing as count gets count plus 1. So count plus plus is not a replacement for count plus 1. That makes sense? Count plus plus, if this said count gets count plus 1, then I could replace it with count plus plus. But that's not what it says. And not only that, but I've told you that in my opinion, it's better practice. Maybe I haven't said this. In my opinion, it's better practice not to put a statement in the middle of an expression, or not to put a statement where you expect an expression to be, right? So if we put count plus plus here, not only are we adding something to sum so far, we're also actually in the middle of this expression changing the value of count. Does that make sense? So the way I have it now, the value of count is not changing. Okay? But if I put count plus plus there, the value of count would be changing, just sort of as a side effect in the middle of what I was doing there. Okay. But I'm glad you asked that, because I get that a lot. Okay, someone's sitting at their computer and they say, "Why isn't my program working?" And I come and I sit down and I look at it, and there's a count plus plus where they meant to say count plus 1. Okay, so that's not a substitute. All right, I'm done talking about for loops. Any questions about for loops? Okay. All right, so what I want to do now is just one more thing to talk about loops before I wrap it up. Is I want to just show you a couple of examples of using nested loops. Okay? And I would say that when you get to nested loops, I think that's the first time where you get to something where it's really kind of hard to get your mind around the algorithm that's happening. Okay? When you do an if statement, it's pretty simple, right? It's either going to execute that code inside or it's not. When you do a loop, it's pretty simple. It's going to either execute the code inside there and go back up to the top, or it's not. When you get nested loops, you can start getting to the point where your brain can't handle what's actually going to happen there when that code gets executed. So we need to talk a little bit about how to try to make that fit in one's brain. Maybe I should speak for myself, but that's how it feels to me. Okay, so I'm going to say, actually, let me get dev C++ up here. And we do the usual things that I always forget to do ahead of time. No auto indent, no smart tabs, and none of that. Font size 14. Okay. Okay. Well, what I'm going to tell you is the best way to think about nested loops is to never try to think about both of them at the same time. Okay? So you kind of try to break it down into its pieces. For example, look at the inner loop, figure out what it does, and then in your mind, replace that inner loop with a description of what it does, what it accomplishes. And then look at the outer loop and pretend that inner loop isn't there. Just think about the conclusion you came to about what it does. Okay? Let's do a couple of examples of that. Let's start with something really simple. Let's write a program that produces the following output. Okay, and let's say that to create this first line here, we could just say cout and then put 4 stars in the cout statement, right? But let's say that I want to keep my code flexible so that maybe I could have the user tell me how wide to make this box and easily get that to work. Does that make sense? So I don't want to just say cout star 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 star. I want to put that in some sort of a loop that prints out a single star so that I can easily control how many stars it actually prints. Okay? And same thing with the number of lines here. Okay, I want to be able to flex on how many lines of stars I have here. Okay? So already before I dive into the code, hopefully you would be able to see sort of what the role of the 2 loops are going to be. The situation we have here is we want to print out 5 lines. So we're going to have a loop that iterates 5 times. And each time through that loop, you're going to what? Describe it in 4 or 5 words. Print 1 line of stars. Right? 4 in this case, but to keep it general, 1 line of stars. Does that make sense? So you've got a very simple loop, counter control loop. It's going to go 5 times, and each time inside the loop, it's going to draw 1 line of stars. So maybe I'll try to start that, and I'm just going to throw good practice to the wind, and I'm just going to put the numbers 5 and 4 right here in the code to keep things simple. Well, actually, we don't want a while loop. It's a counter control loop, right? So we're going to use 4, 4. I'm going to show you another trick here. You can actually declare your counter variable right here in the header of the loop. Okay, so like this. Does that make sense? Count less than 5 because we want 5 rows of stars. Count plus plus. Okay, and then I'm going to write what's going in here is going to be draw 1 row of stars. And that's it. I'm done, right? Someone had a question?
I was just going to ask if you were favorite add or design variables or
I don't think so, actually. The question was, do I need to leave space up here in my notes for more variable declarations? And I don't think I'm going to need any more. Yeah, pretty short. Okay. Before I go, so the next thing we're going to do is we're going to just close our eyes and forget that this loop exists. And we're going to focus just on this right here, and we're going to write the code that draws 1 row of stars. Okay? So do you see what I'm saying where I say, don't think about both loops at the same time? Just think about 1 loop at a time? Before I actually before I actually do that code, I want to just refine this a little bit, and I'm going to try to think of a better variable name for count. Row, right? Does that make sense? This variable is always going to be equal to which row we're on. So I could say row. I could even be more precise, and I could say row count. Because that's what the variable is doing. It's counting through the rows, right? Row count. Row row count. Okay. All right, I'm going to digress for just a second and say I think this is I'm going to talk about variable names for a second. I think this is an extremely good variable name, row count. However, I'm going to say in real life, most programmers aren't going to use row count as their variable name because they're lazy or whatever, you know. They're just going to probably use I for the variable name there. Okay? And to be honest, I would probably do that too because I'm lazy. I don't think using I is better, but it's very common practice. People are used to it, and, you know, people don't like to type. So I'm going to leave it for row count for now, but I'm going to just tell you that. And, you know, if you use I in your for loops, I'll probably be okay with that most of the time. But there's definitely sometimes where you've got a loop, and it's actually going to be really important to identify what that variable is keeping track of in there. So, I don't know, maybe I shouldn't have said anything at all, but go ahead. Is there a reason I picked I? The reason I picked I is that's what everybody uses. Is there a reason everybody uses I? I don't think that's... someone said, is it because it stands for iterator? I could be wrong. I think I's been around longer than iterator has. It's just a common convention. I think it actually stands for int. Whenever you see examples in textbooks and the variable is supposed to be an integer, they use I. Whenever you see examples in textbooks and the variable is supposed to be a floating point number, a double or whatever, they usually use X for whatever reason. So, question. Are we allowed to use I? I was just getting myself in trouble talking about that. If you want to take your chances and use I, you can, but I'm going to tell you that there are going to be sometimes this semester where there's a loop, and it's going to be my opinion that it's really important to have a more descriptive variable name there instead of just I. But if it's just a really basic for loop like this one where there's really not that much going on and it's really just counting the iterations of the for loop, then you could use I and I wouldn't complain. Okay? Sorry I made that so complicated. I probably should have just said, don't use I. That would have been simpler. Okay. Are we ready to write the code to draw one row of stars? Okay. We're going to close our eyes and pretend that the loop up there doesn't exist. And we're just going to say, well, how do we write one row of stars? Int star count. See how I can be extremely precise with my variable names if I want to. Let's stick with pseudocode for a second here. What needs to happen each time through this loop? One star, right? Okay. If I was using I instead of row count here, I'd probably use J instead of star count there. Yeah. Okay, so there's one thing missing from this that I have so far, right? If I run this now, what's going to happen? One long row of stars, right? So I need to see out indel in here somewhere. Where's that going to go? In the first for loop after the end of the inner for loop, right? Okay, because this for loop here is supposed to be drawing one line of stars. And so after I draw one line of stars each time, I have to hit the enter button. Okay. I think I'm done with that example. Let's run it. System pause. There's our 4 by 5 box of stars. Pretty exciting stuff we're doing now. Any questions? I will tell you something about my philosophy of teaching this stuff, which other people, and some of you will probably disagree with, is I would much rather give you like the simplest possible example to teach the concept rather than give you something that does something exciting. That's just kind of my bent. So sorry if you need something exciting to keep your interest up. I'm not very good at that. Any questions about this? Okay. One more example that is going to involve nested loops. Let's write a program that produces this output. Actually, I'm changing my example a little bit on the fly, so I hope it doesn't come back to bite me. But I think I'm improving it. Okay? I wanted to print that. And as always, I want to be flexible so that I can easily change my program to make it go 1 more row or 10 more rows or whatever, right? So in this case, I'm going to actually use a constant for how many rows there are going to be in this picture. So let's go back up here. Okay, I'm going to start off with numbers being equal to 4. All right, so starting with our outer loop, so this is a really good practice to get into when you're writing programs, and that it's kind of decomposing the task into smaller subtasks. That's what we're doing here, right? Instead of trying to think of the whole task at one time, how can we be really organized and think of it in terms of its subtasks? Really important. So how could you describe what we're doing here if you're thinking about you've got one outer for loop? What is each iteration of that outer for loop going to do? Yeah, 1 line. Okay? But same answer as last example, right? So it's easy to do this when you're looking at pictures, right? That's why I'm using pictures here. But so yeah, we're going to write a big for loop that when I say big, really, I just mean the outer for loop that's going to have another loop inside it. Okay, we're going to write an outer loop, and each time through that outer loop, we're going to do 1 line of output. Okay, so let's get that set up for int row count gets 1. And I'm going to start at 1 instead of 0 because that's what's going on my picture. Row count less than or equal to what? Num rows. Everyone okay with that? Row count plus plus. So what goes in here is print 1 row. Right? Everyone okay?
How would you check that out versus back before and row count line if it didn't fit on 1 line?
Oh, how would I do this if it doesn't fit on 1 line? You know, you just kind of give it your best shot. I don't think there's really any great way to do it. You know, I might just finish it up like that or something. Okay. There isn't really a specific cutoff, but certainly if it's going like way across the page, it's probably going to be easier for someone to keep track of if you keep the line shorter than that. Okay. That used to be whatever would fit on a printed page, but we're not printing them anymore. So, but roughly about that. If I was going to go off the end of my screen here, I would probably not do that. I would bounce it down to the next line. Okay, let's write the code to print one row. Going to have a loop that's going to go through and print 0. I'm sorry, it's going to print 1, 2, 3, 4, and so on, right? So for int, I'm just going to call it count this time because that's really all it's doing. I'm going to leave that off for now because I'm not sure yet what exactly is going to go there, but I know the rest of my for loop is going to look like. And then each time through that inner for loop, what are we going to write? Okay. So let's focus in on this inner for loop now. This inner for loop is supposed to count from 1 up to something, right? So each time through the for loop, we just want to see out count. And then probably, a space. Go away. And then when we're done with this inner for loop, what do we need to do? Go down to the next line. Whoa. Okay. All right. The only thing left to do is fill in that question mark. Okay. How high do we want to count in each row? How high do we want to count? As high as row count. So, right. Looking at this picture down here, when row is 1, how high do we want to count? 1. I'm sorry, row count. When row count is 2, how high do we want to count? And when we're on the 3rd row and row count is 3, we want to go up to 3. So what goes here is each time we're always going to count up to row count. Okay? So that does illustrate something, which is that sometimes you're not going to be able to completely ignore the other loop, right? In this case, in order to get this to work, we actually had to kind of go back and look at the outer loop a little bit. Okay, but as much as possible, when you're thinking about this, the way to make it so that it fits in your brain is to, only think about one loop at a time. Any questions about any of this? Okay, I'm done talking about loops, and it's a pretty good stopping point, so I'm going to just stop a little early today. So let me just stop recording here. Don't go quite yet, guys.